Okay, so we know that compounding does give us more interest than simple interest, but like how much better? And if I'm trying to compare two accounts, one that offers me monthly compounding to one that offers me quarterly compounding, and the rates are very close, how can I really tell which one's going to be better? Because more compounding is better, but higher interest rate is better. Well, the way we do that is we kind of level the playing field by finding something called effective yield. That's also called the APR, annualized percentage rate. And what we're basically doing is taking that compounding rate and we're calculating what would the simple interest rate be to get that, if we had that kind of interest. An example will help. All right, so here we have 4% interest compounded quarterly. What is the actual simplest interest rate for that? Okay, well, we're going to use our compound interest formula and say in 1 year, if I had $100 at 4% compounded quarterly, how much would I have? Turns out we'd have $104.06. Okay, so I got $4.06 interest because it was compounded. So it's not just $4, it's a little bit more than that because of the compounding, right? Now, if that $100 had been invested at simple interest, what would the rate have been? Well, we're going to set up a formula or an equation using our simple interest formula. And I'm going to put in the future value, $104.06, and my initial value of $100, my 1 plus R times 1, because we're trying to find the rate, right? If I do all the math on this, distribute, subtract the 100, and divide, it turns out that it would be 4.06 simple interest. So a 4% compounded annually is 4.06 simple interest. Okay, now I'm going to generalize this formula here. All right, so we're going to compare annual simple to compound. So future amount for simple interest on the left, the future amount for the compound interest on the right. You notice there's a piece of 0 in both, so we're going to divide that out. And I'm going to simplify a little bit there with my multiplication. And then I'm going to try to solve for the R on the simple interest side by just subtracting 1. And that is where our effective yield formula comes from. Okay, so here is the effective yield formula. Y, that's what our book calls it, is equal to 1 plus R over K raised to the K minus 1. R is our annual interest rate as usual, and K is the number of compounding periods, also as we've used before. So let's do a couple problems and see if we can use that formula. We're simply going to compare, is 2.5% compounded semi-annually still better than 2.4% compounded quarterly? So more frequent compounding, is that enough to overcome that 1/10% interest difference? So we're going to put everything into those two formulas. We're going to compare the 2.5% semi-annual to the 2.4% quarterly. Grab the calculator, put it in carefully, and work it out. And this is what I come up with. 0.02516, so that's about 2.5% over here. When I do the other one, the 2.4 quarterly, it's 0.02422, so it's 2.42. It's a little bit better. So the higher interest rate is still going to be better, even though there's more frequent compounding with a 2.4%. Right? So it helps me figure out, is that interest rate that's just a little bit lower but more frequent compounding, is that worth my time to go to that bank? Probably not. Right? Let's try one more. Go ahead and hit pause and try to work out this problem and see if the 3.01% compounded quarterly really is better than being compounded monthly at just 2.95%. Okay, let's take a look. So this is what you should have set up. Just putting all those numbers in, the R and the K, into our formulas. Then we'll carefully put it into our calculators. And there we go. So the 2.95% does annually become about 2.99 or almost 3%, which is good, but it's still not enough to to meet up with the 3.01% that's just compounded quarterly, that's actually going to be about 3.4%. So I'm always going to go, unless there's just a teeny tiny like 100th of a percent difference, I'm probably going to go with the higher interest rate despite the compounding frequency. That's usually my better deal. But now we know mathematically we can see and prove why it is.